Everybody, welcome to GLC Networks webinar. We are hope that you are doing well. Thank you for your time and special big thanks to all of you who's doing fasting. Although this Ramadan time you were struggle during the daytime, but still you have courage and patience to join our webinar. We really appreciate that. And for about next 1 hour, we will share and discuss about the topic tonight is IPv6 with MikroTik. During a webinar, if you have any question, you may drop the message in chat box or just unmute yourself and ask question directly. And by the end of the webinar, we hope you will get something good, something benefit and useful to improve your skill and knowledge. So let me introduce you to speaker tonight is Mas Ahmad Mardiansyah. He's a founder of GLC Networks. He is also trainer, mentor, and consultant for an IT and SP. Also have experience in domestic and overseas project. So are you ready with the slide, Mas Ahmad?
Yeah, sure.
Okay, let's get started. Thank you and enjoy the webinar.
All right. Thank you, admin. So the topic today is about IPv6 on MikroTik. So my name is Achmad Mardiansyah, and I'm from GLC Networks Indonesia. Oops. Yeah. So the agenda today will be this topic has some prerequisite knowledge. So we're going to review them. And before that, there are some short introduction about ourselves. And next about so we just want to refresh our memory about how IP works. And then after we understand how it works, and then we'll be talking about the previous traditional IP version, IPv4 in this case. And then we talk about the topic, okay, which is the IPv6 on especially on MikroTik. First IPv6 itself, how it works, and then IPv6 on MikroTik. Okay, so about ourselves, we are GLC Networks. We are based in Bandung, Indonesia. Our areas are training and IT consulting. Oops. So we are certified partner for MikroTik, Ubiquiti, and Linux Foundation. And we also have our own product that is Radius Manager. Okay, looks like it's doubled here. Wow. Okay, so I think I made a mistake here. Oh yeah, okay, sorry. Sorry about that. So my name is Achmad, and I'm based also in Bandung. Linux user, MikroTik, and Ubiquiti, also other vendors like Cisco, and then yeah, other vendor networking. Trainer for networking, MikroTik as well, Linux also, and if you have a LinkedIn account, and then I would like to connect with you guys. About ourselves, our past experience. We did the MikroTik network support in Malaysia, in Congo. Still, in this year, we do network support because we are very limited for doing movement, right? Since this year and since last year, okay, 2020. But we still do some tasks here to support our client. So mostly we do network things like network integrations, and then network upgrade, network implementations, and then also we do software development, mostly that supports the ISP operation. Okay, about the webinar itself, we do webinar every week, okay, with various topics. The schedule is available in the website, in our website, and then we start webinar since 2010. So yeah, that's quite long time ago. More than 10 years, yeah. Wow. And I would like to hear from you guys. So can you please introduce yourself for those who are new coming to this webinar? Okay. So usually there are people from Indonesia, of course, people from Philippines, Africa, and then some from Asia. Okay, so if you don't mind, just introduce yourself here, where you're from, so that uh, at least we know uh, from which country that you're from. Right. Thank you. Okay. Yeah. Thank you, Saad from Bangladesh. Right. So, oh, okay. People from Thailand. Okay. Sawadi. Sawadi Cup. Right. Oh, Titus from Kenya. Okay. From Germany. Wow. Okay. Welcome. Right. So the presentation requires, the topic here requires prerequisite knowledge. So this is not this is not a topic where people can just jump in without any blank mind. So at least before you understand the topics inside, at least you know several things here. At least you know how computer network works. Okay, I know computer, and then I just open the browser, type something on the address bar, and then hit enter, and then ta-da, and then I got what I want. No, it's not like that. So we need you to have more deeper understanding about the more details mechanism on a computer network works. Okay, so after you know how computer network works, and then at least you know how routing works, and of course, at least you know how IPv6, IPv4 addressing is designed. At least you know about the subnetting and then other stuff like that. Right. So thank you very much, guys. I can see some of you already introduced yourself. Thank you very much. Yeah, hopefully you can enjoy this webinar. So, okay, let's discuss them. So about the internet itself, so it's a bit of the history. Initially, it's a research project, and then uh, it's a product of liberalization. So everyone thinks that, oh, okay, internet is good. Okay, let's join the internet and then do something about it. And then internet is everywhere. Uh, many people knows the internet now. Before the internet, as you know, computer networking is already exists, but many are proprietary. So IBM can talk to the IBM, digital to digital, Apple talk to Apple, and uh, things like that. So it makes us difficult to have computer to computer communication. So that's what happened. So after that, we define an standard for communication. Okay, so because uh, so as I said, the computer networking is there, but it's proprietary. Okay, so only same vendor can talk to each other. So this is not a good situation. So that's why we, not we, I mean our our older generations, they define a protocol where people can talk to each other. So protocol means like a language between computer. So we speak in the same language. So that's why we are able to talk to each other. So before the protocol is like this, so this is not good. And after that, we set up a setup of computer protocols like TCP/IP. Okay, so that's why people from different vendor can talk to each other. Okay, so it's simple, as simple as that. So the main idea here is a protocol, a common protocol that is implemented by many vendors, so that we are able to talk to each other. So here, what we are concerned is just the application. Okay, so what you care is your WhatsApp, what you care is your YouTube, right? You don't care about what is the TCP/IP, what is the port address, what is the IP address. You don't care, right? What you care is the internet application. uh, yeah, so yeah, because the details is already been established long time ago. Okay, so our our ancestor there, they still live, by the way, uh, already make a good job for us so that we can have computer communication easily. Okay, so after the internet, just like this, people can be able to talk to each other. Okay, so for those who are old enough, some of you might understand this logo. Okay, so this is Windows, actually, Windows 3.1. So that was my first Windows operating system. This is a Sun Microsystem. This is Apple. Okay, so Apple logo was look like that. This is digital. This is X. This is Unix. Okay, so yeah, those are if you are old enough, and then I'm sure you understand about this logo. Okay, so internet is open, lightweight, global, and neutral. It's supposed to be neutral because yeah, what we need is just to make a communication. Okay, so when we also talk about layers, and then when we have a telecommunications, we also have layers. So started from the lowest layers like this. Okay, it's a physical, and then these cables connected to exchange. Okay, central office. Okay, and then from central office we go to local loop, and then the device. Okay, okay, all start from the device and then connect to local loop on your jack at your house, and then from that going to internet exchange. Not internet exchange, I mean telco exchange, and then after that connect to other telco exchange. That's how we see communication in a layered method. So layered telecommunication, in traditional telecommunication is like this. So we have infrastructure, network, and application. As you can see, the network here is divided into different their own physical network. So previously we have a voice, a copper wire that can deliver voice, and then we have a video network, and then data network. So a long time ago, the network for those technology has their own physical infrastructure. But after the internet, everything goes to the internet. Okay, so there is no network for video, voice, or data. So everything is combined into one single network. Okay, so yeah, so because there are so many vendors, as I said here, vendors need to be able to talk to each other. Okay, so that's why we need standard. So standard is like a language. Okay, like an agreement, how we communicate to each other. So this is what I send, this is what you get, and then this is how you reply. So that is a standard. Okay, and one aspect for addressing, one aspect for the standard is addressing. Okay, so how can you, because we want to make a communication, so that's why we need to have addressing, right? So let's, for example, when you send email or mail or traditional mail, you need to have a destination address and then source address, right? So same thing. Okay, so every time you want to make communication, you need to have addressing, so either source address or destination address. On internet, there is a organization named IANA. Okay, Internet Assigned Number Authority here. So IANA is the super body, is the highest body that manage the internet addressing. So all IPv4, IPv6 is managed by IANA. IANA is not alone. IANA delegates the authority to RIR, Regional Internet Registry, and then RIR delegates to country. So as you can see, we are in Asia Pacific, so we are managed by APNIC. And Europe and Middle East is managed by RIPE. Africa is by Afrinic, Latin America by LACNIC, and then North America by ARIN. So we have 1, 2, 3, 4, 5 regional internet registry that manage the IP address. Okay. Yeah. So internet topology. So internet basically works like this. So every network, okay, so every network must have a global address, okay. So what you get from IANA is a block of IP address like this, okay. So this one is assigned to this one is assigned to that, this one is assigned to this, and then where is your house? Your house is, for example, this is your ISP. So net here is called ISP, okay. So ISP must have a block of IP address, and then if your house is here, and then uh, your house your house is part of the internet, okay. So you just one dot in the big internet, okay. Right, so that's how internet works. So it's a interconnected networks. So if it is interconnected, and then has to be a physical network that connects all of them. Yes, yes, true. Yeah. So the ISP, the provider, is build an infrastructure to connect their equipment to your premise, to your house. Okay, either through a copper wire, long time ago, to a fiber optic, or through wireless. All right. So that's how internet works. And yeah, as I said, this is your ISP, and this is you. Okay, so this is your ISP, and then you are just one node in your ISP. Okay, okay, you are part of them. Okay, and then here we have another network from Google, the network for Facebook. This is other ISP, other ISP, other ISP. We have a Netflix here, and then yeah, many networks that connects to the internet. So internet again is a collection of network. Okay. Uh, let's go more detail. Okay, so previously it was explanation for a high level, so let's go deeper. Actually, when you send something through computer networks, yeah, there is a encapsulation process, and then it's been modeled or referenced with the OC layer. Okay, with the OC layer, we have a 7 layer here, which are physical layer, data link layer, network layer, transport layer, session, presentation, and application. Okay, so we have 7 OC layer, and then in every layer we have protocol inside. So, for example, network layer here, we have IP, we have ARP, we have ICMP, GMP, and so on and so forth. So actually, um, yeah, if you want to be a network engineer, what you need to do is just learn those protocols. Okay, as simple as that. Okay, because protocol are, as I said, protocol is an agreement. Okay, so that's why if we follow the protocol, then we should be able to connect to each other. Okay, okay. This is the example of encapsulation process. So from the top here, this is your application like WhatsApp, Facebook, browser, and then they cannot just send by, the data by themselves. Okay, there'll be an encapsulation process, and then where your data is wrapped with other headers. Okay, here we call it segment or datagram. Here is called packets, and then at the end, before this it's sent to the media, it's called frame. So this is the encapsulation process. When the packets arrive, we call it decapsulation process. Okay, so if we are going to, if we look into closer on each layer, for example, this is layer 4, we can see the format of the protocol. For example, this is layer 4. Okay, in layer 4 we have either TCP or UDP. Okay, so I'm sure you know which one is TCP and UDP, right? uh, yeah, yeah. So that's how the header looks like. Okay, as a layer 4. So below here is the UDP because it has UDP is lightweight, unlike TCP that has a more control. Uh, UDP is usually used for real-time communication. There is no need acknowledgement for UDP, right? So on the layer 3, we have two options. Okay, either you can use IPv4 or IPv6. Okay, so which one is IPv6? This one. Okay, what's the difference here? So here you have in the head IP header, you have two addresses, source IP and destination IP. What's the difference? Big difference with IPv6 is the length of each IP address. Okay, so this is the source address, and then here's the destination address. So it's, as you can see, so this is source IP address. This source IP address becomes 4 times larger, okay, compared to the previous one. So previous one is 32-bit, okay, only 32. But here you have 128, right? So from here to here, okay, yeah, from here to here. So it's very, very long IP address. So that's a significant difference between IPv6 and IPv4. And then down to layer 2, we have Ethernet header, okay, and then also Wi-Fi header, okay, and then when we take a look into the more closer in the encapsulation, so when you type something on WhatsApp, so what you send is just hello, but actually what you send is not only hello, but there will be an encapsulation process throughout the communication links. So this is what you send, this is what you type on your WhatsApp, but this is actually what you send. Okay, so if you use IPv4 and then this is the length, 1 square is 1 byte. Okay, 8 bits. So you can imagine how many bits that you are sending. Okay, if you are IPv6, if you use IPv6, the the address is much more longer. Okay. Okay, so that's the significant difference between IPv4 and IPv6. So IPv6 is much more longer compared to IPv4. Right. Okay, so again, just review. This is layer 2 and layer 3 addressing. So layer 3 focusing on logical address, while layer 2 is for adjacent communication. You cannot ping a computer in America with the layer 2. No. Layer 2 is just for local communication, while layer 3 is end-to-end communication. The IP itself, the IPv4, actually was defined long time ago, okay, with RFC 791. Yeah, it was defined in September 1981. Yeah, so yeah, it's a long time ago. Yeah, with the typewriter here. And then they also, as you can see, this is the header, okay, the header that you see in the previous slide. So this is how they write in the typewriter. Okay. In the 1990s, there will be a revision, a new version for IP, which is IPv6. So IPv6 actually is not the new things, already defined many years ago. When I learned networking for the first time in 1999, IPv6 already there, okay, but nobody is using it. So it's just good on the uh, lab scale. Okay, they are testing. Okay, IPv6 is good. So this is how layer 3 looks like. Still IPv4. Okay, as I said, IPv4 is 32-bit long, displayed in the decimal format. Okay, 2 parts: network part and host part, and then the host part and network part will be defined by the subnet mask here. Okay, so subnet mask. So the IP address is just a bunch of one and zeros. Okay, but they are divided into a network part and host part by this subnet mask. Okay, sorry, so it was not correct. So it's supposed the splitter is here. So as you can see, the purpose for subnet mask is for splitting the bits of the IP address, or either they become a network part or host part. Okay, so this is a layer 3 connection a routing process. Okay, so actually this is the router, and the purpose for the router is to connect networks. Okay, and the network still in IPv4. Okay, this is how it looks like. So those router will develop the routing tables, and then when the packets arrive, and then they can forward to the destination. In the beginning, IP address has no subnet. Okay, of course they have subnet, but the subnet is already defined by the IP address themselves. So in the beginning, it's very simple. Okay, you just only have /8, /16, /24. Okay, uh, but after that, IP address becomes very rare, and then people are proposing the VLSM. So start from here, start from 1995. When you write an IP address, you have to write something. Okay, so you know IP address like this, and then you have to write slash something, /24 or /20 or /21 or whatever. Okay, so there is no more class A, class B, class C, please. Okay, we don't use class A, class B, class C anymore. It's already gone. Okay, it's already gone since 1995. Please. Okay, if you are still talking about class A, class B, class C, please don't do that anymore. Right, because we are using VLSM, and then we can use the classless. Okay, classless inter-domain routing. Okay, so previously it was classful. Now it's classless. Okay, there is no class. So that's why when we develop a routing table like this, okay, so CIDR defined in 1993. So it's a long time ago. So that's why when we develop IP routing table like this, so we have to define the prefix, right? We have a /17, /24, slash whatever. Okay. As I said previously, we have a subnet here, and this is how you do the subnetting. Okay, so you have an IP address, and then you have the slash. Okay, here's the slash. Okay, oops, sorry. So here's the slash. Okay, /30, /18, /16, and then this is the total number per slash. Okay, and then if you compare to class C, this is how you compare to the class C. Is it similar to the class C or higher than class C? If you write in the decimal format, it's going to be like that. Almost all router now is supporting slash format. Okay, so like /20, /30, and so on and so forth. But in some routers, for example, Cisco, you have to put net mask like that in the decimal format, like 255.255.255.0 for /24. Okay, and then we have private address and public IP, public address. So internet is very popular. Yeah, it was defined in RFC 1918. Okay, why? Why internet is very popular, and then many address and many IP address already been used, and then if you don't use this technique, and then the IP address already obsolete long time ago in 1990s. Okay, so the RFC here defined that the IP address should be classified into two parts, two types. First is a private, and then the public IP. So private we don't use. We only use private in our internal networks, and then here's the block. Okay, And then if you want to go to the internet, and then we have to translate, okay, the private IP to public IP. The process is called network address translation, or NAT here. So the purpose for NAT is to translate private IP to public IP address. Next is Bogon. Bogon is IP address that is not allowed to be appeared in the internet. So those prefixes that is not allowed in the internet is called Bogon. Example is the prefix for private IP. Yeah, other is prefix for non-allocated IP address. Yeah, so that can be classified as Bogon as well. And then we have router. Switch is layer 2, hub is layer 1, router layer 3. Sorry. Oh, I'm not well. Sorry. This is how router works. Okay, so this is at least you understand how the ARP works. Okay, so the host A sent a frame to the router, and then the host A knows the router IP address by using the ARP request here. Okay, so the purpose for ARP is to get the MAC address of particular IP address. Okay, so on the other side we have two networks. So this is network 1, this is network 2. Okay, and the bridge connected by a router here. The router is the one in the middle. So when the packets arrive in the second network, okay, on the on my right hand, okay, so the packet needs to be forwarded into the destination, which is the host B. So in this case, there will be an ARP request also here. Okay, so that's the purpose for ARP. So we know the IP address, but we don't know the MAC address. So the ARP will guide us to understand the destination MAC address, so that we can send the frame to the appropriate destination. Okay. Here's the routing table. As I mentioned before, every router will develop their own routing table, so that when the packets arrive, and then the router will look up at the routing table to forward to the destination. Now it's the IPv6. So what's really changed? Well, IPv6 does not interoperate with the IPv4. So IPv6 and IPv4 is two different animals. Okay, they are not compatible to each other. Why it's not? Well, because if IPv6 failed and then IPv4 has no effect, that's the different. That's the purpose, right? So it's a good design. Yeah, so IPv6 and IPv4, they're running independently. So is something wrong in one of them, they will not affect each other. Okay, but this is also the benefit and also the drawback. Why? Because we need to support both addressing. Okay, so they are working independently. Yeah, a different design intention. Simplify IP header to remove unnecessary fields. Okay. So IPv6 has a fixed length. Okay. Uh, Compared to IPv4. Okay. So that's why in IPv4 we have padding, right? Padding. In IPv6 already fixed. So that's why the processing is very much faster compared to IPv4. That's because of the fixed length. Okay. Expanded address space. So this is what's really changed on IPv6. Okay, compared to IPv6, compared to IPv4. So IPv6 compared to IPv4 is has a larger address space. Yeah, address is 16 bytes. Okay, compared to IPv4 is only 4 bytes. Yeah, longer, and then no checksum. See, at the network layer, no hop by hop fragmentation. So there is a path MTU discovery aligned by 64 bits. Okay, authentication and privacy capability. So that's why I said IPv6 IPsec is is designed to be operable with IPv6. Okay, in IPv4 IPsec is just an extension, but in IPv6 is part of them. Again, no more broadcast. So this is good. Yeah. Why? I think it's also logic because if you are doing ARP broadcast and then your network will be filled with the broadcast. Okay. And then there is no ARP. Yeah. So because there's ARP requires broadcast to the network, it with IPv6, you should not have a broadcast anymore. So there is no ARP. There is no address resolution protocol. And then we will be talking about the replacement, a kind of replacement of ARP. Okay, I have one question here. What is the best PWA web, IPv6 or IPv4? PWA means progressive web application. Well, that uh, IPv6 and IPv4 is on layer 3. What you are talking about is layer 7, okay, which is application layer. So it's a different layer. So nothing to do with IP. So this is the comparison, okay, between IPv6 and IPv4. So this is IPv4, IPv6. Well, yeah, name is the same. Okay, so version, source address, destination address. The red one here is the not keep it. So we just remove this on IPv4. Okay, we don't use it. So IPv6 has a simple header compared to IPv4. Okay, name and position change. So actually here traffic class is from type of service. Payload length is total length. Next header is for uh, yeah, it's the protocol. Okay. Hop limit is the time to live. Yeah, time to live is this one, right? So same function, same functionality, but yeah, different name. Okay. And then we have a new field label here on IPv6, which is this one, flow label. We don't use it now, perhaps in the future, but we can identify a flow of connection. Okay, so hope you can see it. So IPv6 representation. So previously with IPv4, the way you put an IP address is just, for example, 4.3.3.1/24, right? With IPv6, you cannot do like this. What you are doing is this. Okay, so this is your IPv6 addressing. So we use a colon. Okay, you use colon, colon, colon. Okay, and then we use hexadecimal. Okay, hexadecimal. So we call it group. Okay, called nibble, if I'm not mistaken. Yes. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So total is 128. Okay, and then here we have 8 group. Okay, so 128 divided by 8 group equals to how much? 16, right? 16 bits. So 16 bit per group. Yes. Yeah. So one character here means 4 4 bits. Okay. Yeah, one bit. Yeah, 4 bits is you can handle from 0 to F. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay, so that's how you compare to IPv4. Okay. can host, I have a question, can host with IPv4 again communicate with IPv6 address? Of course not. Yeah, see, as I explained here, okay, IPv6 is not compatible with IPv4. They are different animals. As I said, different animal. Okay, IPv6 cannot ping IPv4. IPv4 cannot ping IPv6. So they are different animal. So that means in your interface, you have to configure both IP address. Yes, correct. Does that answer the questions? Hopefully, yes. So we have some tips here, for example. So this is 00, right? And then here you can do it like this, okay? Or you can represent it like this, okay? If all 0. Okay, this is representation. Representation means all 0, okay? Yeah. So if there is a colon colon, so what is the characters in this one? Okay, it's called yeah, it's called 0. Okay. So for example, yeah. So in the URL, so if you are accessing IPv6 address, okay. So what you access is usually HTTP, right? HTTP colon slash slash 1.1.1.1, right? This is IP4. Yeah. With IPv6, the address that you need to type is like this: HTTP. Okay, we have a square bracket here, a square bracket here, square bracket here, and then the port number. If the port is a standard like HTTP port, which is port 80, you don't have to put it like that. Okay, so here, this is how you access IPv6. So that's why typing IPv6 address is very, very time consuming. Yeah, I'm just exaggerating. Uh, yeah, uh, I'm just putting too much. Yeah, but guys, the IP address in IPv6 is quite long. Okay, and then yeah, I mean, just get used to it. And better if you have a better way, you'll be using FQDN or fully qualified domain names. Okay, so that's why we need DNS. The functional the role of DNS in IPv6 is very, very crucial, because otherwise we have to spend our time typing the address of IPv6, which is quite long. Okay. Okay. Again, the presentative. Okay, it's done. This is rule. The type of IP address, again, we have in IPv4 we have broadcast address, right? We have non-broadcast address. Okay, so here I think this is quite new. Okay, we have multicast, we have broadcast. Okay, with IPv6 we have multicast, we have anycast, we have unicast. Okay, so that's the IP addressing. Uh, Now IPv6 on MikroTik. Okay, so actually IPv6 support is not enabled by default. As you can see, when you buy a MikroTik for the first time, usually IPv6 is disabled. Okay, so you go here and then click enabled and then restart, and then you can check the IPv6. Okay. Now the IP address assignment. Okay, so this is quite interesting. IPv6 actually working with two types. Okay, the way you assign IP address. Okay, so this is your router. Okay, your IPv6 router. Okay, and then this is the switch. Okay, connect to here, and then here's your client, 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 client. Okay, simple network, correct? So Here you are using IPv6, and then what you need to do is, this is your gateway, right? And then you need to assign IP address to the client again. So this client needs to have IP address, correct? Okay, how can you assign IP address to the client? Well, the first method is called SLACC. This one is quite new compared to the IPv4. Yeah, it's a stateless address auto configuration. Yeah, so there's no state, so stateless. Okay, stateless. SL is stateless a address auto configuration. Yeah, auto configuration. So SL is stateless address auto config. Okay, so this is one way you put an IP address. Okay? Either you have two choice. Okay, you can use SLACC or DHCP v6. Okay, uh, so with DHCP v6 we have the new thing compared to IPv4 is this PD. PD means prefix delegation. Prefix delegation. Okay, so this is how it works. Okay, so so as I said, in IPv6 there is no need for NAT. Okay, so there is no NAT in IPv6. Why? Because the address space is very huge. As you can see, 128 one it's 128 bits. Okay, so it means that 2 to the power of 128 addresses. Okay, uh, addresses. This is huge, man. 128, 2 to the power of 128. It's huge. So, so that's why there is no need for NAT. Why? Because we can put IPv6 address to any objects. You can put IPv6 address in your shoes. You can put IP address in your laptop, of course. Yeah, you can put IP address in your hair, for example. You can put one IP address in your nose. Why not? Okay, because the address is very huge. Okay, 128, man, crazy. So that's why. So for example, so here we have a router. So this router one delegates the uh, um, prefix, because this router will have a client, another client, right? Okay. So for example, router one has, so I'll be using IPv4, right? So for example, 1.1.1 uh, 0 slash, oh sorry, 1.1.0.0/16. Okay, so this is the a big IP address. So I want to delegate one prefix to this. So this one will get 1.1.1.0/24. Okay, so we can do that. We can delegate prefix to with IPv6. Yeah, Yeah, it's called PD. Okay. So previously, what you have here, for example, is 1.1.2.0/24, for example. And then here you assign dot 5, for example. Here you assign dot 6, right? Because this is the end device. But with IPv6, you cannot do that. You can do that, but there is an extension where you can assign a prefix instead of a single IP address. Okay, so that's why it's called PD. It's called PD, prefix delegation. Okay, so these are new in IPv6. Okay, so the one that is circled with red here is the new in IPv6. All right. So how to assign IP address to the client here? Yeah, as I said, is the explanation of the previous slide. So first you can use SLACC for end user. You can use DHCP v6. Okay, either you can use for IPv6 for end user. Okay, so this is not available in the router OS yet. So if you want to assign, and then you can use SLACC. Okay, or you can assign DHCP v6 PD. Okay, prefix delegation. So yeah, this one you can use on MikroTik. So how you define the SLACC? So this is IPv6 address, okay, and then this is your address, and then you take it from this pool, and okay, and then assign it the bridge one, and then here's the DNS settings, and then this is the ND network discovery. So the client will do the ND, okay. So on the router side, so this is router. Okay, so the router slide, this is switch. Okay, this is the client. Okay, so from the router side, they will do SLACC. Okay, basically saying that, okay, everybody, I'm here the router. Okay, if you need a IP address, please contact me. Okay, that's how the SLACC uh, uh, yeah, works. Okay, and then from the client will do ND, network discovery. Okay, so if you are using IPv6, you will do network discovery to the router. Is there any router here? Okay, yes, here. Okay, I'm using SLACC, and then okay, here's your IP address. Okay, so it's like that, and then here's the PD. Okay, so this one is quite interesting. This is quite new. Okay, why? Because we are delegating the prefix. Okay, so previously you just single. Okay, you can in IPv4 you say, okay, so your address is so this is your router, and then this is your client. As I said earlier, this is switch. Okay, okay, so you are .5, you are .6, you are .7, you are .8, right? But this one is router. Okay, instead of you give them 8 or something, yeah, okay, so this is .9. You also give them, okay, you can use this IP address, this prefix. Okay, so it's 1.1.1.0/24. Okay, so you will use this in your network here. Okay, so that my router understand, okay, so if I want to route this address, okay, and then I will go to router, this router. Okay, so this is how you define the prefix delegation. So this one is quite interesting in IPv6. Oh, I have a question. IPv6 still use an IPv6? IPv6. IPv6, sorry. Okay. Oh, okay. I have several questions here. Is there any IPv6 like IP public and private? No, it's not. As I said, it seems that you didn't uh, follow my explanation here. Okay, so there is no NAT. Okay, IPv6 is very big. Okay, so there is no need for like private address or public address. Okay, so no IPv6 uh, about this concept. Okay, this concept is about private and public is only available on IPv4. Why? Because we want to save the IPv4 address. Okay, to save IPv4. Okay, so the main reason we do not is to save IPv4 address. And that's the main objective, main reason why we do NAT, why we have a private IP, we have public IP. That's to save IPv4 address. Why? Because IPv4 is intended in the only for lab, okay, for lab for testing, but it becomes very popular in 1990s, in 80s and 90s. So yeah, and then at that time, IP addressing is very generous. Okay, you can get /8 easily, or /24 or /16 easily. Okay, at the time, because they don't expect that IPv6, IPv4 become this huge adoption. Okay, so hopefully that answer questions. Next is from Agung Lutut. Is IPsec again? Sorry, IPsec. Sorry, man. IPsec is used on IPv6. Yes, IPsec is part of IP6. IPv6. Sorry. Yeah. So as I said, this is the okay here. See, okay. So this is the basic difference between IPv6 and IPv4. Okay, so this is v6, this is v4. Okay, with with the with v4. Okay, there is a possibility that the option here is doing something. Okay, so that's why the length of IPv4 is can be varied. Okay, can be from here or from here. So the length of the header is varied. Okay, so that makes the processing of packets is slow, because when the packets arrive, uh, the router needs to check, okay, how long is your header, okay, from here to here, how long. Okay, so that one requires processing. It's like when you do programming, and then there will be an if, okay, if blah blah blah, then blah blah blah. So that if requires one processing power. Yeah, for a small amount of packet, it's okay. It can be ignored. But if you receive 1 million packets per second, then that can be a problem. So that's why in IPv6, the header is fixed. Okay, here. And then we can define here the next header for IPsec. Okay. Okay, so next. Oh, I got questions. IPv6 doesn't do that. Means device has a public IP address. Is there a security method? Yes, using firewall. Yeah, thank you for Master Robert. Yeah. So NAT again, NAT is not security. Okay. Thank you, Marcel. Yeah, again, NAT is not for security. Okay, in the beginning, NAT is designed for saving IPv6 address. Why? Because in the late 80s, in the early 90s, IPv6, I mean IPv4 is used anywhere. Okay, in America, in Europe, in many countries. Okay, if they don't do something about it, and then how the IPv4 already finished long time ago. Okay, so that's why they invent NAT. Okay, let's do the NAT, and then yeah, we can still do IPv4 up to today. But NAT has many problems, right? Yeah, for those who are working in ISP, right? Problems. Agree with me? Okay. For example, FTP. Okay, FTP requires end-to-end communication. In the middle, when you change the IP address because of the NAT, and then there will be a problem. Okay, so that's why, yeah, we have to work on FTP. That's why we set up the passive NAT, for example. And also when we do port forwarding, okay, that one can be a problem as well. Especially if you run FTP with security, with encryption. So basically, in the normal form, FTP has no encryption. Okay, but with NAT, if you run FTP with encryption and then it's behind NAT, then you have problem. Also with VoIP, okay, we have seen many problem with VoIP that causing by NAT. Oh, yeah, it's crazy. So if you have a VoIP server, okay, guys, if you have VoIP server, better if you put IP address, I mean public IP address on VoIP server. Do not put it in the private IP address where you do a port forwarding on it. It will give you very headache. Okay, so let's get back. So at least you need to get an understanding first about how IPv6 works, and then after that, it's very easy to implement in the MikroTik. Okay, so first, if you are, this is for router. Okay, so this is for router. The one that is doing SLACC is the router, not your computer. Okay, now your computer will do the ND. Okay, ND, it means network discovery. So from the router side is the SLACC, from the client side is the ND, network discovery. If you do DHCP, MikroTik do not support DHCP for end client. Okay, they don't support. But if the client is router, okay, if the client is router, and then at the main router, okay, this is the main router, main router. Sorry, my handwriting is not that good. Yeah, you will do set up the DHCP. Okay, so DHCP which provide the a PD here, okay, pool. So it's a prefix delegation. Okay. And then from the client, the HCP-v6 PD client, this is what you can do. Okay, so this is, we have a DHCP-v6 client, and then we have pool. Okay, so the pool from, so this is main MR, main router. Okay, so this is let's say lower router. Okay, so main router will give prefix. Okay, prefix to the lower router. Okay, and then the prefix is from pool, and the pool when the lower router receive, and then the pool will be available on here automatically. And then you can see the prefix, the length, and then the expire time. Okay, so this is how you define the DHCP-v6 client PD. Okay, PD. Okay, so this is the HCP client, and then so on and so forth. Okay, IPv6 consequences. First, no NAT. Okay, again, no NAT. Because there is no NAT, no hotspot. I'm sorry, guys. So if you are thinking about running hotspot on IPv6, no, you cannot do that. Okay, why? Because hotspot requires NAT a lot. Okay, So if you're running hotspot on IPv4, the client uh, the router will set up a NAT rules on router. Okay. Okay. So no ARP. Okay. No address resolution protocols. And then for routing protocol, we need to adapt with the new protocol. For example, BGP. BGP requires IPv6. Okay. And then for OSPF, there is OSPF v3 that is intended to support IPv6. Okay. Okay. Anything else? No. Well, it's already 9 o'clock here. I don't think we have time for live practice because presenting the concept of IPv6 requires time. Okay, maybe next time. Right. So yeah, if you are interested, you can join our training. You can inform admin, and then for a schedule, it's available on our website. Okay. We have also Facebook page. Also, slide will be available on SlideShare, and recording will be available on YouTube. Okay. Any questions? If no, and then it's picture time. Yeah.
Should be.
Picture time.
Guys, no question, yeah?
Guys,
Already,
any
I think.
questions so far? Are you getting?
Are you still there?
Yeah, are you getting better or more worse?
But anyway, Mas Ahmad, thank you so much for your sharing time.
Yeah, yeah,
It's
sure.
been a great time, and then together. And guys, thank you so much for your participations. Okay, so is
Time for
anybody there?
yeah, perhaps
Oh, where is the picture?
yeah, guys,
Face,
please
please.
turn on your camera to so that we can have a photo session here. So again, oh, okay, there is a question here. Must we use IPv6 now? Now that depends on your ISP. Most of the ISP now still providing IPv4. Okay. Yeah, depends on your ISP. So in our past project, some clients in China, and also in America, their ISP already provide what is it? Already provide IPv6. Okay, so they just turn it on and they just get IP address, and then off you go. You can join the IPv6. Also, not all application supports IPv6. Yeah, some website they are still running on IPv4. Yeah, so that's one reason why people are not uh, adopting the IPv6. Okay, right. So I think it's a picture time. I will take a picture here. 1, 2, 3. Okay.
Tiho, where are you? Actually, you are
Yeah,
the
okay.
customer
Getting
of
1, 2,
our
3.
webinar.
Okay. On the next page. Okay, 1, 2, 3. Done. All
All
right,
right.
guys. Thank you very much again for your attention. Okay, next time there will be uh, I think better better time for having a lab or things like that. Yeah. See you later in the future. Thank you very much.
Thank you. Bye.
Thank you and goodbye.
Thank you. Bye bye.